So at the end of section 2.4, you're going to be looking at one way to apply the standard deviation to determine the distribution of data values. Now, when we use the empirical rule, the first thing that we have to do is make sure that we're dealing with symmetric, or what we call bell-shaped data. Now, the way that you determine the shape of a distribution, this was referenced at the end of section 2.3, is by looking at its histogram. So what we're talking about here is a data set whose histogram is symmetric. That means high frequencies in the center and then frequencies kind of trailing off on either side, where you get this mirror image. And the reason we call this a bell-shaped curve is because if we were to draw a line over the top of the histogram, it would resemble the shape of a bell. And that's what you're seeing here when the percentages are defined for the empirical rule. All right, now the second thing to note is that the empirical rule defines 3 specific intervals of data. One that holds 68% of data, one that holds 95%, and one that holds 99.7%. These percentages are fixed, okay? These percentages you're not calculating. These percentages have already been determined, and you can use them just like you would use the information that you pull from a formula. All you have to do to apply this is figure out what these intervals look like based on your standard deviation and your mean. Okay, so let me give you an example of what these intervals are going to look like. All right, so again, if you're going to use the empirical rule, the first thing you need to do is make sure that you have a bell-shaped, symmetric distribution, and make sure that you know your mean and your standard deviation. All right, so here I'm told that the mean monthly utility bill for a sample of households, remember sample mean is a value of X bar, is $70. And I'm told the standard deviation of that sample, that would be a value of S, is $8. And then right here, this is what's important. I'm told this follows a bell-shaped distribution. That's how I know that I can use the empirical rule. And when I use the empirical rule, what I'm going to do is I'm going to look at intervals that are based on the mean and the standard deviation. Okay, so the mean is always the center. All right, the mean for this data set was $70. So I'm going to place that right here at the center. And then I'm going to move away from that mean by my standard deviation. Okay, standard deviation here is 8. So if I go up 1 standard deviation, I'm going to be at 78. If I go back 1 standard deviation, again, which is 8, then I'm going to be at 62. Okay, notice all I did was I subtracted the standard deviation of 8 here, and I added the standard deviation of 8 here. Now, what the empirical rule tells me is within 1 standard deviation, which is what I just did, I will find 68% of my data. Now, it defines this for 3 different intervals, and they're all based on the standard deviation. So if I do this again, right, 2 standard deviations would be going up 8 more. That would put me at 86. And then going back 8 more, that would put me at 54. Okay, again, I'm just moving away from the mean by my standard deviation of 8. And what the empirical rule says is within 2 standard deviations, which is where I am now, I'll find 95% of the data. And then if I do this one more time, if I move out another standard deviation, so 8 more on the high side would put me at 94. And then 8 more on the low side, moving back 8 more, is going to put me at 46. And so now that I've moved 3 standard deviations away from the mean, the empirical rule tells me that that interval between 46 and 94 will hold almost everything, 99.7% of the data. Okay, if you define these three intervals based on your mean and your standard deviation, then you're going to be able to answer whatever question you're being asked. So I've laid the intervals out. Now I'm going to go back and look at the question. The question says, estimate the number of households whose monthly bills are between 54 and 86. All right, so if we look at our distribution, right, 54 to 86 right here, that's 2 standard deviations away from the mean. And the empirical rule tells me that will hold 95% of the data. Now, sometimes you'll be asked for the percentage, in which case you would be finished. This one's a little bit different. It asks you to estimate the number of households. So I'm going to have one last step here, and that is to apply that percentage, right? 95% is just 0.95, to the number of values that I have in my sample, which is 40. So to convert this to a number of households, I'm going to use the empirical rule to get the percentage, and then I'm going to apply that to the number of households. And that will tell me that I would expect 38 households to have bill amounts between $54 and $86. Okay, and it works the same for each one. So like if the question had said between 46 and 94, I would have said, well, that's 3 standard deviations. I would have changed this to 99.7%, and then I would have applied it to the sample size the same way. Okay, so that's one thing you're going to be doing is figuring out what these 3 intervals look like and using it to determine what percentage or what number of data values fall within 1, 2, and 3 standard deviations of the mean. The other thing that you're going to be doing is using these intervals to determine if you have unusual values. Okay, so this is the same distribution that we're dealing with here. So what I'm going to do is just copy down those 3 intervals that we found. All right, so again, just to remind us, we had the mean of the center. 1 standard deviation went from 62 to 78. 2 standard deviations went from 54 to 86. And 3 standard deviations went from 46 to 94. Right? All that we already did, so I'm just copying those over. Now, if you want to use this information to determine if you have data values that are unusual, then what you're going to do is you're going to look for any values that are more than 2 standard deviations away from your mean. All right, that's this interval right here. That's 2 standard deviations away from the mean. It runs from $54 to $86. Now, anything within that is going to be fine. But if you have values that are beyond 2 standard deviations, less than 54, more than 86, they will be considered unusual. So if we scan our list of data values here, all right, there's 2. The only 2 values that go outside of this range are 52, that's below 54, and 98, that's above 86. So unusual values would be 52 and 98. Okay, anything that's more than 2 standard deviations away from the mean is considered unusual. Now, if I want to go even more extreme and talk about values that are very unusual, then what I'm going to do in that case is look for values that are more than 3 standard deviations away from the mean. All right, 3 standard deviations was my interval from $46 to $94. Okay, and again, anything within that interval is okay. We're looking for things that are beyond 3 standard deviations. So of the 2 unusual values, right, 52 is not past the 3 standard deviation mark. It's within 46 and 94. But 98 is beyond the 3 standard deviations. So of those 2, I would say, well, 98 is considered very unusual because not only was it more than 2 standard deviations away from the mean, it was also more than 3. Okay, so you're going to be looking at examples with the empirical rule, both looking at specific intervals of data and applying those percentages, right? So 68, 95, 99.7, and then using those 3 intervals to determine if data values are unusual or very unusual.